Good morning. This tutorial I'd like to explain the concept of second order derivative, which is the derivative of a function second time. In second order derivative, if we take just one step backward, then first order derivative, as you have written as dy by dx, this represents the rate of change of y with respect to x. Second order derivative, when you do, then it is differentiation of the first order derivative. If we have a function like y equal to fx, then first order derivative dy by dx is f dash x. Now if you find that this function f dash x is differentiable, I mean if we can differentiate once more, then differentiating dy by dx, again we get the second order derivative, that we write symbolically as d dx of dy by dx. d dx, you know, it is rate of change of certain quantity. So if rate of change of y is there, we write this one as dy by dx. If rate of change of first order derivative is there, we write this one as d square by dx square or f double dash x. Higher order derivative, higher than the second order derivative, also possible, that we write as d cube y by dx cube. Fourth order d4y by dx 4, like that. Okay. So second order derivative, this also has some geometrical meaning, like dy by dx, the first order derivative, geometrically it represents the slope of tangent drawn to a curve. Here second order derivative will represent the concavity or convexity of a curve, that I'll explain in another class. Okay. Now, when we are going to calculate derivative of a function, that is second order derivative, then what are the steps you are going to follow? These two steps are very simple. Just find the derivative first time, that you will get as y equal to fx. If you take the first order derivative, is going to be dy by dx equal to f dash x. F dash x is differentiable, then dy by dx is going to be d dx of dy by dx, that is d square by dx square, or symbolically sometimes you write this one as f double dash x. Similarly, second order, third order, all these can be defined. Now let us go for the example where a very simple function fx equal to x cube is involved. If you find its first order derivative, this will give us 3x square. All of you know it. This is by the rule, the derivative of x to the power n is nx to the power n minus 1. So it will give us 3x square. When you differentiate 3x square once more, it will give us f double dash x is equal to just 3 into derivative of x square, that is 2x. So there will be 6 into x. Okay. Now let us go for one numerical example where we will take the function in the form y equal to x square plus 3x plus 2. What will be the second order derivative of this function? Okay. This y equal to x square plus 3x plus 2, you all can see, if we differentiate it first time, it will give us x square derivative is what? 2x, 3x derivative is 3, and 2 derivative is 0. So you will be getting 2x plus 3 into 1 plus 0, that is 2x plus 3. If you differentiate this function once more, it will give us d square by dx square, that is d dx of dy by dx, nothing but 2 into 1 plus 0, that is 2. If you are going to apply it for y equal to x cos x, that first order derivative if you do, it will give us x into d dx of cos x plus cos x into d dx of x. Cos x derivative, all of you know, minus sin x, so it is minus x sin x plus x derivative is 1, so cos x into 1. Okay. Now first order derivative is done. If you are going to differentiate once more, then I have to apply the chain rule on x sin x once more. That not chain rule, that product. So there it will be product rule again, x sin x into derivative of sin x plus sin x into derivative of x, and derivative of cos x minus sin x is coming. So finally you will be getting minus x cos x minus sin x minus sin x. So this is very easy to understand, because when you differentiate once, that is done in accordance with the formula you have learned in class 11 or 12. Second type derivative, when you do, then also you do it by using the common formula of differentiation. Now suppose you are going to do y equal to x cube log x. What will be the second order derivative of this function? Let us see. For y equal to x cube log x, if you find dy by dx, then again by chain rule it will give us x cube into log x plus log x into x cube. So this will give us x square plus 3x square log x. When you do it second time, then derivative of this thing again required, we get 2x plus 3 into derivative of this thing, x square log x. Again you apply the product rule over there. This will give you x square into derivative of log x plus log x into derivative of x square. Now it is very easy to complete all these steps here. You all can see that log x derivative is 1 by x, x square is 2x. So by common formula we are getting. These are just examples where you will do differentiate second time. Differentiating first time you get dy by dx, second time when you differentiate again, this will be d square by dx square. So e to the power x sin 5x I am doing. Again you can see product of two functions are there. That first function is e to the power x, second function is sin 5x. When you are going to differentiate by using chain rule, this will be e to the power x into derivative of sin x plus sin 5x into derivative of e to the power x. What is derivative of sin 5x? You all know it. It will be 5 into cos 5x, and there again derivative of e to the power x is e to the power x only. So it is e to the power x into 5 cos 5x plus sin 5x. And now we differentiate the function once more. So we have to apply the product rule by taking e to the power x as the first function, 5 cos 5x plus sin 5x as the second function. Okay. So again apply product rule there. You can see there are two functions, e to the power x into this thing. So e to the power x may be the first function and this is the second function. Use the product rule, e to the power x into derivative of this whole thing. You have done many differentiation of this kind where sin 5x, cos 5x, all these are involved. That for sin ax it will be a into cos ax. For cos bx it will be minus b into sin bx. Here I have used the same rule there. Cos 5x differentiation I am doing, sin 5x like that. So finally it is reduced to the power x into 5 into minus sin x like that. We get e to the power x into 10 cos 5x minus 24 sin 5x. So next one is just another example. I think there is nothing special. All these sums taken from NCERT book. That lot many sums will find there of this kind. Here the new thing in compared to the previous one, their index of e was x only. Here it will be e to the power that 5x or 6x is there. That when you differentiate, 6 will come outside. Derivative of e to the power 6x going to be 6 into e to the power 6x. So first time derivative you can do smoothly, just differentiating once. Second derivative also you can do smoothly. Just apply the same rule again for all the functions. Okay, but in some problems steps becomes complicated when they're asking you to prove something. Okay, before solving all those kind of sums, I would like to say about tan inverse x. What do you observe for tan inverse x? If you differentiate first time, it will give us 1 by 1 plus x square. Second time, just u by v method, that is v into du minus u into dv. So derivative of 1 will be 0, 1 into derivative of 1 plus x square. So we get minus 2x, 1 plus x square. Okay. Now, when we are going to do it for, say, this kind of thing, that y equal to log of log x. Again, apply the same procedure, just dy by dx, log of log x is function of function. You apply the chain rule over there. Derivative of log x will be 1 by log x into derivative of log x will be 1 by x. Then again by u by v method, x log x whole square, x log x into 0 minus 1 into derivative of that. So finally you got second order derivative of log x. Let us go for tan inverse x. I think it is similar to our previous one, so I need not explain. Let us find the variety here, that suppose cos inverse x we are doing NCERT problem. They asked you to find d square by dx square in terms of y alone. In the result, y will be there. See, gradually conditions are coming into the problem where second order derivative concept you are going to apply to prove something. First time differentiation, if you do cos inverse x, all of you know it is minus 1 by root 1 minus x square. But x is cos y, you substitute there, you get dy by dx minus cosec y. Again differentiating cosec y, there will be minus or minus cosec y cot y into derivative of y is dy by dx. That dy by dx you take from the first step, that is minus cosec y, if you substitute there, then the whole expression going to be minus cosec square y into cot y. Okay? So this you all understand. Here the something special was there. You have to express the result in terms of the variable y. This is not possible to express all answers in terms of given function y. But when they ask you this question, be sure that there is some way to get. That I showed you in the previous sum. This one is a very special one, but the transformation is possible. Everything can be expressed in terms of y, but it's not always true. You cannot do it always. Now do it for this function. It's a good question. They have asked you to prove something where y equal to given. You show that x cube, x square y2 xy1 plus y equal to 0. How you are going to do? Just do first time differentiation. The only difference between this sum and previous sum that you have to get the answer very convenient form. I will say that. With x cube into y2 is there. No other quantities, sine, cosine will be there. So you have to adapt some special method when you are going to solve it. See what we have done here in the beginning. When first time derivative is done, after that we have transferred x on left side. We have multiplied by x on two sides. It's going to be xy1 minus 3 sine log x plus 4 cos of log x. Differentiate once more. Then again x will appear on the right side. Then again you shift it on the left side. The advantage is that you are getting the thing which was given here in the numerator again. So you replace it by y. And then finally it is changed to x into xy2 plus y1 equal to minus y. So it is proved that x square y2 plus xy1 plus y equal to 0. Okay. Another sum where they have asked you to prove something, that if y equal to tan inverse x whole square given, you prove. This is a very important question. And you must use the method I told you in the previous sum, where we have replacing or cross multiplying. Replacement property I showed you in one sum, that where you have to get the answer in terms of y. And then transferring, I showed you another sum like 3 cos log x plus 4 sin log x. For this special one, tan inverse x whole square, after first time differentiation, my suggestion is to transfer 1 by 1. That when you do first time differentiation, it will give us 2 tan inverse x into tan inverse x derivative 1 by 1 plus x square. You cross multiply both sides by 1 plus x square. So 1 plus x square y1 is 2 tan inverse x. You differentiate this one once more. then 1 plus x square into y2. y1 derivative is y2. That when you differentiate once, it will be y1. When you differentiate twice, it will be y2. I mean, y1 stands for dy by dx, y2 stands for d square by dx. So this expression, when you are going to differentiate, you use product rule here. First term differentiation of 1 plus x square. What does it give? It will give us 2x. First term differentiation of y1. What does it give? It will give us y2. So use the product rule here for this. 1 plus x square into derivative of y1 plus y1 into derivative of 1 plus x square equal to derivative on the right side. So 2y1 plus x square is coming on right side. Cross multiply, then answer is reached. But if the student is very very strict to say that I'd like to solve it by finding second order derivative and putting the value on the left hand side, I'll say that you are most welcome. But their number of steps by that method will be more than number of steps we have used here. It's very easy to get all the steps here. So we'll remember it in this manner in most of the sums which we are going to do in the following classes also, that I will tell you to remember this way. Differentiate first time, cross multiply whatever you get on the right hand side in the denominator, you bring it back on the left side, then differentiate once more, then divides both sides by 2y1 in most of the sums. You get the answer. Okay, so I'll show you in another class where tricky sums, where not only this, some manipulation is also required. Okay, so you start doing your NCERT problems. Most of it is done here, exercise problem. So you revise the examples, sums, you revise the exercise problems, you do it, and then you approach it from NCERT example. Okay, see you again.